Welcome. We're going to work through this past exam question. It is taken from VCAA 2017, paper 2, question 4. And as you can see here, we've been given a table of values in which we have the years starting from 1900 going all the way to 1980, and also the area in hectares. So each of these areas have a corresponding year, as you can see here. So 1930 and 120 hectares. All right, we're going straight to part B, which is asking us to perform the log 10 transformation to the variable area. So that means we're performing a log 10 transformation to this variable right here, and determine the equation of the least squares line that can be used to predict log 10 area from year. Now, this statement right here is useful to us because it's telling us what the EV and the RV is. If you can predict the log 10 area from the year, that means the year explains the area. Let's continue reading. Write the values of the intercept and slope of this least squares line in the appropriate boxes provided. Round your answer to 3 significant figures. Now, as you can see here, we're going to put in values into these boxes. We have log 10 area is equal to something plus something times year. So this is where we can confirm that we've identified the EV and RV correctly, because we know that our RV exists here and the EV is there. So we've done that correctly. It's kind of given to us. Now, we know that our least squared regression line is in the form y is equal to a plus bx. So that means we need to put our a value into this box and our b value into that box. That's what we need to do in this question. And also make sure that we round to 3 significant figures as well. Okay, so let's give this a go. The first thing that we're going to do is just plug in this data into our CAS. So if we come to our CAS now, I've already done this. I put in year, I started at 1900, and I went all the way down to 1980 and put in all the corresponding area values. Then what I need to do is perform a log 10 transformation to the area. So I'm going to come here and I'm just going to call this L area. And then I will come to this box. I will go equals. Then I will go control log. Remember, you don't have to put a 10 there. It assumes a base 10. Then I'll come over here and I'll go there and I'll go to area. And I'm going to put area there and then hit enter. And then it will populate that for me. I now need to generate a least squares regression line. I'll put my cursor over here and then just go menu, statistics, stack calculations. I'll go linear regression a plus bx, hit OK. My x is going to be the year and my y is going to be the log area, because you're performing the log 10 transformation to your response variable there. So we hit OK. And we're going to get some numbers out here. So now we can put these numbers into their correct spots. So our A is negative 14.396. We have to make sure that we round this correctly. So if it's 3 significant figures, it will be negative 14 point. Now I need one more significant figure. So I'm going to round this 3 up to a 4 because of this 9. Then we come over to B. Now this is where you have to be careful, because if we look at our B value here, whoopsie daisy. If we look at our B value here, it's 0.00853. We want 3 significant figures, so none of these zeros count. 853 is what we're after, but then we have to figure out whether or not we have to round this 3 up. As you can see, if you put your cursor over it, it gives you the full number out here, and this is what you need to be looking at, because you need to see, oh look, it's 0.00853.8. So therefore, this 3 will be rounded up to a 4. So I'll come over here now, and I'm going to write 0.00854. That's going to be my answer. So just make sure you can read that off correctly. Before we move on, we've got the answer there. That's all correct. So we are technically done. And we are done. It's not technically, we're done. Another way to generate your least square regression line is to go control, add doc, add data and statistics, put in the correct X and Y. So our X is year. This is going to be the log area. Then we can go menu, analyze, regression, and then show linear a plus bx, and there it is again. So just another way of doing it. You, of course, in an exam situation, would not do it both ways. You'd be silly to do it both ways. But you can see this is another way of doing it. Negative 14.4 and plus 0.00854 there. So just another way of thinking about it. All right. Let's now look at the examiner's report to see how people went with this question. So let's move over here. And as you can see, these are the answers that we generated, negative 14.4 and 0.00854. Only 37% of the state got the full 2 marks here. Let's look at the mistakes that were made. It says some students did not recognize the rounded slope value from part A was required value in part B. Don't worry about this sentence here. Because we only looked at part B, we don't have to worry about what part A said. So this sentence here won't make any sense, so don't worry about it. Let's look at the next sentence. Some students appeared to have renumbered the values of the variable years 1, 2, and 3, etc. This was not asked for and was inappropriate given the increment of 10 in the given values. So what this means is that some people weren't putting into their CAS calculators 1900, 1910, 1920. Instead, they were going 1, 2, 3. That wasn't asked for and was inappropriate. So don't do things that the question does not ask you to do. Very important. Perfect. There is our answer. Let's just get rid of this to make sure it's all nice and clear. We've put in the relevant information there. Hopefully you found this helpful and doable using your CAS calculator. See you later.